This video is about graphing natural log functions. The first example says, graph the function f of x equals ln of x, or you could say the natural log of x. Remember, the natural log of x just means log base e. So that's the same thing as log base e of x. Now, because the e value is here, again, it's an irrational value, I'm going to get out a lot of decimal answers. There's only one that's not going to be a decimal here. And so in previous videos, if we had a log function, we would convert it to exponential, pick y values, and solve for x. But because the base here is e, it's not going to do me much good to convert it to an exponential and then pick the y values. So I'm just going to go ahead and leave it as the natural log and just use my calculator, because my calculator does have a natural log button, right? So I'm going to input x values. But the thing we have to remember about log functions is that the domain is going to be 0 to infinity, meaning close to 0, but I'm not going to input 0, right? I'm not including that as part of my domain. I can't put it in. In fact, if you tried, so if I put in a 0, I tried to take the natural log, it says you can't do it because 0 is not part of our domain. So the next number I'm going to pick might be, let's just plug in 1 and then 2 and see what happens. So if I do the natural log of 1 first, I get 0. So that's a nice value. If I do the natural log of 2, again, I'm going to round it to the nearest tenth. I'm getting approximately 0.7. So f of 1 gave me 0. F of 2 was just the natural log of 2, which is approximately 0.7. Let's do 3. Again, I'm just using my calculator to approximate these. So the natural log of 3, I get about 1.1 after rounding to the 10th. And f of 4, so natural log of 4, I get approximately 1.4. Let's go ahead and do one more here. So take the natural log of 5. I get 5, approximately 1.6. So we can see it's kind of slow moving here. But there is a value that I haven't picked that I should probably consider, such as a fraction or decimal. So something between 0 and 1, because I can't pick 0, but let's see what happens when I plug in, just say, a half, 0.5. So let me go ahead and fill this in real quick. 1.4, 1.6, and then do one more. I'm going to take the natural log of a half, and I get negative 0.7. So that was an important one to do because we were getting a negative value there. Let's go ahead and graph these. I have 1, 0, nice value, 2.7, and 3, 1.1, 4, 1.4, 5, 1.6, so just kind of slowly moving up there. And then we also did a half. So x was a half, and we got negative 0.7. So about a third of the way down. Remember, this is a log, and logs should have this general shape. And that's exactly what we're getting. It's going to get close to the y-axis, but never cross it. And then it's going to go up kind of gradually this way. So our range for a log is negative infinity to infinity. And this is a log without any shifts, right? And we notice it is the inverse of the e function, which had a domain of negative infinity to infinity and a range of 0 to infinity, versus the log had the flip-flop. The domain was 0 to infinity and the range was negative infinity to infinity, because they are inverse functions of each other. Go ahead and try to graph the next example. Alright, let's look at what's going to happen here. So on this one, I have the natural log of x plus 3. So now when I put something in, I'm going to constantly be adding 3 to it. So based on previous videos, we know that a value in with the x is going to shift it left and right, versus if I had a value out here, that would shift it up and down. So in general, it usually ends up going the opposite way of whatever the sign is. So we're thinking it might shift negative 3. So I can't plug in negative 3 because negative 3 plus 3 would be 0, and I can't take the log of 0. Even the natural log of 0, I can't do it. So I can't plug in negative 3. But let's go ahead and plug in negative 2.5 maybe, get a decimal in there, negative 2, let's do negative 1, 0, and 1, and see what happens. So I have f of negative 2.5, which when I plug that in, I'll take the natural log of negative 2.5 plus 3, but I have to do parentheses first. So it's the natural log of negative 2.5 plus 3 is positive 0.5. And we already did the natural log of 0.5. And we know that's going to be negative 0.7. So we did that right up here. Okay, if I plug in negative 2 next, I'm going to get f of negative 2, which is the natural log of negative 2 plus 3, which is the natural log of 1, and we know the natural log of 1 is 0. Then I'm going to do f of negative 1. The natural log of negative 1 plus 3 will be the natural log of 2, and the natural log of 2 is 0.7. Again, I'm just stealing these numbers from up here. I know the natural log of 2 is 0.7, so right there. You can also use a calculator for these. So that was 0.7. If I do f of 0, that'll be the natural log of 0 plus 3, which is just the natural log of 3, and we know that's going to be 1.1. And f of 1 would be the natural log of 1 plus 3, which is the natural log of 4, and that is 1.4. Again, just ln of 4 is approximately 1.4. You can also use your calculator. And now I'm going to graph these. So I had negative 2.5 for x, gave me negative 0.7 for y. Then negative 2, 0, negative 1.7, 0, 1.1, and 1, 1.4. And if you feel uncomfortable, if you're not sure what that's looking like, just plug in more values, right? So f of 2 would be ln of 2 plus 3, which is ln of 5, which is approximately 1.6. So 2 was about 1.6. It's going to have the same shape. We know we can't go past negative 3 because I can't plug in negative 3. right? Negative 3 plus 3 would be 0, but ln of 0 gives us an error. So I'm going to get close to negative 3, but I'm not going to cross it. Got an asymptote there. And then it's going to gradually go up like that. So, what is the domain? Domain means how far left and right. So we can see it's going to get close to negative 3. So it's all about here. I can't input 0. I can't input negative values. So it's going to get close to negative 3, but not include it, and go right forever. The range is how far up and down it goes, left and right forever. So because of this value, it shifted left 3.